thanks everyone for joining us today. For those of you joining us again today, welcome back. I hope yesterday was filled with great presentations and you learned a lot about what we do here in the Geography Division at the Census Bureau. And for those of you joining us the first time, welcome. Hopefully we'll have a bunch of other great presentations and discussions today. For those of you joining the first time, I'd like to go over a bit of housekeeping information. As mentioned earlier, this event will be recorded. For your convenience, it will be uploaded to the Census Academy site with all the supplemental materials relating to this webinar within 30 business days. We welcome written questions during the webinar. Please submit your written questions using the Q&A panel, which is either at the bottom center or the bottom right side of your WebEx screen. There'll be a couple of little dots. You'll be able to open that up. Please take a moment to locate that now. Once you've found the Q&A panel and you'd like to ask a question, make sure you choose all panelists from the drop-down menu. This will ensure everyone will see your question. Also, we ask that you do not include any personal or business identifiable information with your questions. We'll keep the chat open as we will provide key links and other resources throughout the day. Keep in mind you won't be able to respond to the chat, but this is for us to send out links and other resources and information related to the presentation. My colleagues and I will be monitoring the Q&A panel. As time allows, we will answer your questions directly through that panel, or if there's time, we'll share your questions with the presenters. All the questions and responses will be posted with the webinar materials on the census.gov/academy site within 30 business days. So if we don't get to your question today, either wait for the materials to post, or feel free to email us at geo.geography@census.gov, and we'll reply to your questions directly. As you know, we are in a virtual environment, and sometimes technical difficulties might occur. If you're having issues, try a different browser such as Chrome, or try logging out and coming back into the session. That often works. If you're having audio issues, try selecting the computer audio or calling into the webinar via phone. Now let's get started with our first session of the day, which will be, as you can see, powering artificial intelligence readiness through strong metadata practices. We will then have an open discussion with census geographers, which will be a great opportunity to ask any questions you may have about the work we do, the projects, programs, or products we create. We'll then have a short break, and then starting at 2 o'clock, we'll have a bunch of great sessions from our partners here at the Census Bureau in the data dissemination area, as well as a couple of really interesting outside presenters. So we hope you stick around all day. All right, now for our first session. Allison Schaefer-Blackwell is a geographer in the Geography Division of the U.S. Census Bureau and is a passionate advocate for open data and AI readiness. Driven by the mission to make datasets highly discoverable and actionable for decision makers, both human and machine alike. Welcome, Allison. Can't wait to see what you have for us.
Thanks, John. And thanks, everyone. Thanks for being here this afternoon to discuss powering AI readiness through strong metadata practices. As John said, my name is Allison Schaefer-Blackwell, and I'm a supervisory geographer at the Census Bureau. And in the Geography Division, I lead the practices that ensure our geospatial metadata products are high quality, interoperable, and ready for the public to use. I also serve as a subject matter expert in several federal-wide initiatives supporting metadata and open data practices. It's no secret that there's a massive amount of data available today for policymaking and problem solving. But available doesn't always mean usable. To turn that data into insight, you first have to find it, access it, and most importantly, understand it. And today we're going to talk about how metadata is the bridge that makes all of that possible. To guide our discussion today, I've broken this session into 3 core pillars. First, we'll ground ourselves in the metadata foundations, defining what it is and more importantly, why it's the backbone of our modern data systems. Next, We'll move into guidelines and best practices, and I'll provide actionable guidance and best practices specifically through the lens of AI readiness to make metadata machine actionable, ensuring data is fully discoverable and ready for modern automated decision making. Finally, we'll take a behind the scenes look at the Geography Division's metadata practices at the U.S. Census Bureau. I'll walk you through our specific life cycle and how we manage these processes at scale to support our mission and our public data users. My hope is that whether you're just learning about metadata for the first time, or if you're a seasoned metadata practitioner or veteran, you'll walk away with ideas or considerations to apply to your own work. But before we can dive into the how, we need to be clear on the what and why, which we'll cover in this metadata foundations portion. Traditionally, we define metadata as data about data, but that's a little bit too vague. In the context of AI and modern decision making, we can also think of it as the DNA of a digital asset. It provides the necessary context that makes raw numbers meaningful. Without metadata, a dataset is just a pile of bricks. With metadata, it's a structured building. It tells us the who, what, when, where, and why, which is exactly what data users and AI models need to know before processing information reliably. While our title today focuses on AI, I want to be clear. Metadata is first and foremost about the user, both human and machine. For the human user, metadata is that common language. It's what allows a policymaker or a researcher to open a data set and immediately understand the who, what, and why without having to directly call up the data creator. It helps build trust and prevents the misuse of information. For the AI user, metadata is the machine blueprint. AI models don't have intuition. They need structured instructions to know if a data point is representing a coordinate, a date, or a category. And at the Census Bureau, we don't just provide files. We provide the story of a file. For example, if we provide a geospatial boundary, a human needs to know what the vintage of that data is so that you're not using a 2010 boundary data set for 2024 problems. The AI needs that same vintage information structured as a metadata tag so it doesn't hallucinate a trend that isn't there. Without metadata, AI isn't learning, it's just guessing. Essentially, metadata is that bridge that ensures that what the human intended is what the machine interprets. When we look at a single robust metadata file, we find that information is organized in three essential layers or metadata types: descriptive, structural, and administrative. While they serve different purposes, they work together within that one record to provide a complete picture of the data. You can think of the descriptive metadata as the discovery layer. This includes things like the title, keywords, and abstracts. It's what allows a human to find the data and understand its story. Then we have structural metadata, which is kind of the technical blueprint. It describes how the data is organized, its format, and how it was processed. This is the layer that truly powers AI readiness, as it gives the machine the map it needs to navigate that data file. And finally, we have the administrative metadata, or you can consider this the governance layer. It sets the rules for how the data is managed and used. This covers rules like who holds the rights to this data set, when it expires, and any limitations on its use. By including all this information in a single metadata file, we can ensure that the human intent and the machine action are unified, providing a complete and reliable roadmap that allows the data's full context to travel with it wherever it goes. In today's world, data is being created faster and with more complexity than ever before. We have massive amounts of information right at our fingertips, And our customer base has expanded to include humans, computers, and AI users alike. But we have to ask ourselves, what good is all this data if we can't find it? What good is its value if we don't know its intended purpose or exactly what information that it's representing? This is where metadata shines. Metadata is that key that allows any user, AI or human, to locate these data sets and unlock their potential. Metadata serves four critical roles. First, it ensures beneficial data sets can actually be located. It allows a user to judge the data's fitness for use for their own purpose. It provides context or the why behind the what behind the data. And it enables existing data sets to solve new problems years later. Now that we've talked about the concepts of metadata, I want to pivot toward how we actually put those ideas to work. Identifying what metadata is just the beginning. Its true value is found in how we apply it in our day-to-day data management. In this next section, we're going to walk through the best practices and guidance that help us move from simply maintaining data to creating assets that are truly ready for a modern automated world. First, it's difficult to talk about metadata and dive into modern best practices without mentioning the FAIR principles. FAIR stands for findable, accessible, interoperable, and reusable, and these principles emphasize machine actionability as humans are increasingly relying on computational systems to discover and process data. These principles were first published in 2016 as the FAIR Guiding Principles for Scientific Data Management and Stewardship by a diverse set of stakeholders representing academia, industry, funding agencies, and scholarly publishers. They were created to improve the infrastructure supporting reuse of scholarly data and to design and endorse this concise and measurable set of principles, which are now built into so many data management systems. The FAIR principles aren't just a technical requirement. They're a guide for making sure that the hard work that we're putting in to this data actually reaches the people and the systems that need it. When we ensure that metadata is findable, accessible, interoperable, and reusable, we're making sure that our data can stand on its own in any environment. In these next slides, we'll dive into how we can apply FAIR practices in our metadata. So the first step in FAIR is findability. For data to be used and have value, it must be discoverable for both humans and machines. The fundamental problem we're fighting here is the challenge of undiscoverable files. Valuable data that's practically hidden from the tools and the users that need it. To solve this, we can apply these three practices. First, assigning a globally unique and persistent identifier. Our metadata can't just be in a flat file sitting in an isolated folder. It must have a permanent ID that never changes, ensuring that an automated script or external server or system can reliably locate, bookmark, and reference this record over time without that link breaking. Second, using rich metadata to describe the context, quality, and characteristics of data so that the data doesn't get lost in the shuffle. Automated tools operate with zero human intuition. If we want an application or system to accurately evaluate our data, we have to provide exhaustive documentation detailing exactly how, when, and why the asset was created, along with specific quality thresholds. And third, the metadata must explicitly include the identifier of the dataset that it's describing. This creates an unbreakable structural link between the descriptive metadata record and the actual dataset, and it ensures that no matter where the file travels or how it's harvested, its documentation stays bound to the data itself. Once a user finds the data, they need to know how to get to it. Accessibility is about clearly defining the rules of the road on how the data is accessed. The core problem we're trying to solve here is potential for broken data pipelines. A scenario where a machine or an outside analyst knows that a file's data set exists, but hits an immediate structural or administrative wall trying to retrieve it. To prevent this, we can focus on these three distinct accessibility practices. First, utilizing communication protocols that are completely open and universally implementable. This means serving our data through standard universally recognized channels like HTTP and FTP. By relying on an open source protocol rather than a proprietary handshake, we ensure that any standard software application, external script, or web crawler can connect to and read our data streams without needing any special, paid, or custom-built translators. Second, providing the exact conditions under which the data are accessible. Automated tools cannot guess at permissions and licensing. By clearly outlining the precise rules of the road right inside the metadata, such as authentication requirements or usage limits, we give external systems a predictable roadmap so they know exactly how to safely acquire access. And third, ensuring that the metadata itself remains fully accessible even when the underlying data is no longer sustained or is restricted. This is a critical rule for long-term system stability and historical archiving. If a specific data vintage or physical file is taken offline, its metadata record must stay public and searchable. This prevents established automated workflows from completely crashing when they encounter a legacy reference. The machine can still read what the data was and verify its historical context, even if the file is moved offline. Interoperability is where that bridge between metadata, computing, and AI really comes into play. It's about ensuring that data can talk to other applications and workflows. The major problem we're fighting here is system isolation, where a high-value asset is trapped inside a unique structure and can't communicate with the outside world. To solve this, we can execute these three specific practices. First, using a formal, accessible, and broadly applicable language for knowledge representation. Our metadata can't rely on custom text or proprietary formatting. By using globally accepted open data languages, we ensure that the external software applications, databases, and programming scripts can instantly read and parse our files right out of the box. Second is utilizing documented and controlled vocabularies. Automated systems can't deduce what a specific code or an abbreviated label means. By binding our data to clear, authoritative, and documented data dictionaries and code lists, we make sure that a machine always knows the exact definition of those defined variables. And third is explicitly specifying the relationships between data sets. Our metadata must map out how a data set links to other relevant files, geographies, or historical updates. This provides external workflows with a clear network map of how our data interacts with the broader data ecosystem. And finally, the ultimate goal of FAIR is to optimize the reuse of data. Here, we're essentially solving a communication gap. Currently, when AI users or human users retrieve data, they're often missing the context needed to make sense of it. They end up guessing whether the data is reliable or legal to use for their project. We can eliminate that guesswork by focusing on these areas. First is providing clear usage rights for the data set. Algorithms can require explicit green light to use data. By putting clear machine scannable licensing and permissions directly in the metadata fields, we can eliminate any legal ambiguity and give automated pipelines the confidence it immediately to immediately utilize our public data. Second is providing detailed provenance that led to the creation of the data set. This is all about establishing an auditable chain of custody, documenting the exact lineage of the data file, detailing where the data originated, who compiled it, and what processing steps it went through over its life cycle. And third, incorporating relevant community standards. We don't invent our metadata rules in a silo. We adopt the specific formatting standards that the broader geospatial and statistical communities expect. For instance, like the ISO geospatial standards that we depend on here in the geography division. When we provide this level of detail in our metadata, we eliminate any guesswork. We give future users and automated systems the confidence to reuse data accurately, knowing its history and authority. And while the FAIR principles give us a wonderful high-level framework for data quality, preparing for artificial intelligence requires us to take those ideas a step further. We have to look at our data through the lens of a machine. It's no longer enough to make data simply machine readable, where a computer can merely locate and parse data file. We must achieve true machine understandability, where a generative AI system can accurately interpret meaning, context, data lineages, and internal relationships. Metadata acts as the structural framework that shapes how AI models process, interpret, and generate insights when responding to user queries. To ensure data sets can be accurately discovered and utilized by these systems, consider these best practices for metadata for AI readiness. First, ensure completeness and accuracy. This is our primary quality control defense against the problem of AI hallucinations. For an algorithm, the metadata is the ultimate source of truth. If information is missing, include documentation about data anomalies, unknowns, or deliberate gaps within the data, as AI models will attempt to bridge those blanks using unverified generated logic. Exhaustive and accurate documentation ensure that the insights returned are just as reliable as the authoritative source data. Second is to provide documentation in multiple formats to satisfy both human and machine requirements. Human readability ensures that researchers, analysts, and developers can evaluate context and make informed, appropriate use of data. And machine readability is what allows automated data processing workflows to ingest and parse our documentation with limited human intervention. By providing both, we can support the traditional analyst while simultaneously fueling automated workflows. Third is utilizing industry-specific standards and accepted schemas while evolving them for machine understandability. For geospatial data, our foundation relies on universally accepted schemas like the ISO 19115 suite. This solves our consistency and predictability problems across the broader geospatial community. However, to make this foundation AI ready, we need to take those robust ISO standards and present them in web-native structured linked formats like JSON LD. This allows for AI agents to crawl, map, and index our metadata with the same programmatic ease they navigate a modern API. This dual-layer approach ensures that our products are structurally sound and globally discoverable by machine agents. And fourth is publishing metadata at multiple levels of granularity. To keep things simple and easy to search, we moved away from giant single-file records. Instead, we can split our metadata across 3 clear and distinct layers: document level, content and dataset level, and variable level. Document level metadata provides high-level descriptive information like title, author, and publication date. Content and dataset level metadata describes the structural properties, relationships, and processing logic of the files so that automated systems can technically slice and process that data. And variable level metadata goes all the way down to the micro level, detailing the exact fields, columns, data types, and values used in the data. By providing metadata at these levels, we allow AI systems to pinpoint and retrieve exact chunks of information. And when a user asks a generative AI model a question, this stratified approach ensures that systems don't get lost in a massive unindexed archive, but can instead pinpoint the exact authoritative fact each time. Now that we've established our 4 baseline best practices, let's look at the explicit properties required to achieve them. The properties listed on this slide represent the specific AI-relevant metadata elements that are critical for modern-day data engineering. These are our core structural components that allow automated systems to successfully process our data. So first, let's look at how to establish basic documentation and discovery. Elements like title, author, publisher, and keywords provide that essential text description that search engines and AI models use for initial indexing. However, to make this discovery reliable over time, we can use a persistent identifier to lock in that unchangeable digital anchor for that file. And then we pair that with temporal coverage and the update and modification dates so the system explicitly knows what time window that data represents. This ensures that an AI model doesn't make critical computation errors by accidentally feeding outdated legacy data into a real-time calculation. Next, we have to look at how the machine interprets the actual data structure. Algorithms can't guess at an abbreviated column or deduce how data was originally compiled. To resolve this, metadata must provide explicit linear provenance, giving the machine a step-by-step history of how the dataset was constructed over its lifecycle, and this must be paired with deep variable definitions and data dictionaries. By documenting these exact parameters, data types, and attribute values, we ensure that the AI accurately interprets statistical fields instead of assigning its own wrong assumptions to raw column headers. And then finally, we have to establish the rules on how the data can be legally and safely used. Large language models and automated workflows need an explicit machine-readable validation before they can utilize an asset or integrate it into an analytical workflow. Fields like rights and licensing, along with access limitations or restrictions, provide clear legal boundaries in a format that algorithms can instantly parse. When we back this up with explicit statements on intended use, data quality metrics, and comprehensive documentation, we remove all ambiguity. This gives automated systems the explicit validation they need to safely utilize and trust the data. To wrap up our discussion on guidelines and best practices, it's important to emphasize that we don't have to design our metadata frameworks from scratch. These 2 resources highlighted on the slide are readily available for metadata practitioners to use and implement directly into our workflows. They provide practical, actionable blueprints for our operational strategies. The first is the FGDC Technical Guidance for Data.gov and GeoPlatform. This is published by the Federal Geographic Data Committee and serves as a hands-on technical framework for managing national geospatial data assets, but really it can apply to any geospatial or other data asset. It directly bridges high-level policy goals with the day-to-day mechanics of the FAIR principles we discussed. When we talk about ensuring our data assets are discoverable and formatted correctly for public repositories, this guidance provides the exact checklists and standards to follow. It's an excellent tool for ensuring that geospatial datasets remain transparent, interoperable, and fully accessible to the wider community. The second resource provides the modern horizon for our data workflows. This is the Department of Commerce's Guidelines and Best Practices for Generative AI and Open Data. This document was released in early 2025 and was developed by a specialized working group from agencies within the Department of Commerce, and it establishes a clear, practical playbook for formatting open data sets so that they can be seamlessly and accurately ingested by large language models and automated systems. This text outlines those exact steps needed to shift from moving beyond simple machine readability to achieving true machine understandability. And by integrating these resources into workflows, we can confidently ensure our metadata transitions from a passive log into a modern, active, and AI-ready asset. So now that we've covered this strategic landscape from what metadata is and the FAIR principles to making data AI ready, let's shift from theory to practice and look at how these ideas actually work on the ground at the Census Bureau. In this next section, we're going to go behind the scenes to look specifically at the Census Bureau's geospatial metadata. We'll pull back the curtain on our internal workflows and show how we're translating these universal best practices into our everyday geographic metadata products. First, I want to give you a lay of the land of a few things that drive our goals and decisions at the Census Bureau. So the Census Bureau's role in the metadata and data world is to be a data producer and provider. So our main focus is on helping the data user. The Geography Division publishes and provides many different public-facing geospatial resources in multiple formats. You might have heard about some of these yesterday in the GeoForum, but some of these products include our Tigerline shapefiles, cartographic boundary shapefiles and KML files, geodatabases, geopackages, map services, and our online map viewing application, TigerWeb. Our goal is to make our data fair so that data users can benefit from the products we're providing and to ensure that our metadata displays properly in various portals and that this metadata is usable in different software. To do this, we have to ensure that we have high quality metadata to support our products and data users. Our main concern is ensuring that data consumers have the information they need to best utilize our data to solve their problems. In addition to wanting to benefit our data users, we're also mandated to publish our data sets that are recognized as National Geospatial Data Assets, or NGDAs. NGDA data sets are those that have been designated by the Federal Geographic Data Committee, and they must meet certain criteria such as being used by multiple agencies, being applicable to achieve presidential priorities, or are required by statutory mandate to meet mission goals of multiple federal agencies. 30 of the Census Bureau's currently produced Tigerline shapefile datasets are considered as NGDAs. And this means we're required to publish these NGDAs to platforms such as data.gov and geoplatform.gov by the Geospatial Data Act of 2018. Each year, the Census Bureau harvests our annually updated Tigerline shapefile metadata to data.gov and geoplatform. As I mentioned, this product includes 30 national geospatial data assets and 19 non-NGDA data sets. Because each of our shapefiles is created at different geographic levels or partitions, for instance, our county data set is provided at the national level, so there's one shapefile, whereas our county subdivision data set is produced at the state level, so there could be up to 56 data sets provided or data files. And additionally, our road centerline data is produced at the county level. So there could be up to over 3,000 individual files. In total, we create and harvest over 33,000 metadata files each year. And this volume drives a lot of our decision-making processes. So to ensure everything's accurate, consistent, and delivered on time, we rely on a dedicated internal workflow. Let's transition now to look at the actual mechanics of that life cycle and see how this process kicks off. Our metadata workflow, seen here on this slide, provides us with a structured roadmap to systematically create, perform quality control, and harvest our metadata each cycle. Our metadata workflow can be broken down into 5 phases as shown on this diagram. And as you can see, it all begins with the preparation phase. Next, it goes into the development and creation phase. We're actually making the metadata files. From there, we move into validation and quality control. Once quality control is complete and all files are reviewed, we enter into the harvest preparation phase. And then finally, we hit the harvest phase. Now we'll zoom in on each of these phases and look closer at how we tackle these. The first step in our workflow is our preparation phase. This is where we do a lot of our heavy lifting and fundamental legwork before even a single metadata file is actually generated for a product release. One of our first priorities during this portion is determining which standards are applicable for the products we have at hand. This isn't a step that we have to take every year, but when we have a new product or we hear of new standards implementation, we look into this and make sure that we're applying the latest standards. We actually happen to be in the middle of doing this and applying the ISO 19115-1 and -3 standards. Even when we're not planning on a standards update, we do make considerations annually and just kind of make sure that no new guidance has come out and things like that to make sure that we incorporate everything necessary into our metadata. So you've probably learned at this point that standards are critical because they define that strict structural format that have to be followed. They also specify exactly what information is required, ensuring that our data is ultimately interoperable, predictable, and useful for automated workflows. When we're evaluating which standards to apply, we look at 2 primary factors. First, we try to base our selection directly on the data format or the product type. So whether a product is a vector shapefile, a raster layer, a gridded dataset, or a purely tabular dataset, we choose a standard best engineered to describe that unique structure. Second, we operate under the technical framework provided by the FGDC. They dictate a core set of standards that we can consider using that help keep us aligned with the broader federal data community. So once we choose our standards, we go back into the preparation phase. And after looking at the broader landscape of standards, the absolute hard constraint is compatibility. Before we can actually adopt a new standard, we must confirm that it's going to be 100% compatible with open data portals like data.gov and geoplatform.gov, as well as mainstream industry software applications. If those external platforms and applications don't support a specific standard or schema, our files would not be able to be harvested or used, so kind of defeating the purpose. Once our compatibility is locked down, we then deep dive into further analyzing those standards and other reference resources, some that we've discussed earlier today, and we carefully map out the guidelines from those resources and other statutory mandates, such as the Open Government Data Act. We use this analysis then to evaluate our existing framework. Currently, we utilize an internal metadata schema, which we call our Geospatial Product Metadata Standard, or GPMS. And as we're reviewing these external requirements against our internal GPMS, we identify exactly where our internal schema needs to be updated to support any new guidance. We look for structural gaps in our templates to ensure that we add the correct metadata fields to represent the suggested information. And while we're doing that, we simultaneously start planning what specific data values we would need to use to satisfy both the formal guidance and the practical needs of the end user. From there, we translate these findings into concrete software requirements. We work closely with our software development team to provide the specifications that instruct the metadata creation software to pull the correct information and variables from our internal databases and map them precisely into the corresponding fields of our updated GPMS templates. So this means that we have to ensure that both the underlying database values and the templates themselves are completely synchronized and current. Finally, we use this phase to kind of start prepping for testing and review. We identify any new quality control utilities we might need and determine what updates need to be made to our existing validation tools so that they can properly handle any new adopted standards or schemas. And then additionally, if we are moving to a new standard, we have to update our file transformations so that we can translate the metadata from our internal schema to the expected format. So once we have all of our requirements, schemas, and databases updated and primed, we're officially ready to transition from planning to execution. So we'll move next into our next phase of development and creation. So due to the immense volume of geospatial metadata files that we're producing annually, we have to rely heavily on automation. The custom software used to programmatically generate our metadata is developed and maintained in-house by our Decennial Information Technology Division, or DITD. And as you can see by the model on this slide, the creation workflow follows a structured automated flow. So first, we maintain all of our core values, variables, and attributes inside a central database. The workflow itself is set into motion by DITD software, which connects that database and maps the data directly into our internal GPMS template. Once the data is created in our internal format, we run an immediate validation check right at the starting point. This allows us to verify that the schema was indeed followed, and we make sure that the correct structural elements are present and any mandatory text is populated. If the file doesn't pass this initial test, it goes no further. We kind of restart that process, working with the developers, making sure the information in the database is correct and the software is correct, and kind of troubleshooting. Third, once we verify that those initial GPMS files are looking great, we execute our transformation process. So while our internal database populates our custom schema, remember, we have to deliver formats that public portals and industry applications can actually read. So to bridge that gap, we utilize XSLT files or extensible style sheet language transformation files. And these style sheets act as a translation engine, programmatically converting our previously verified internal schema metadata directly into the fully compliant, internationally practiced ISO standard. And to help you visualize this, we're going to give a clearer view on what our internal schema looks like side by side with our public-facing output. So this comparison perfectly illustrates why we choose to drive our internal creation process through our own schema first, rather than trying to directly build into a rigid final standard. So simply put, our internal schema is a bit cleaner. It doesn't rely on namespace definitions. It's significantly less nested, and it's much more streamlined to work with on a day-to-day basis. If you look at the raw structural scale, the native geo schema is only 434 lines of code. And once that same exact information is processed and expanded into the fully compliant ISO schema, it balloons to almost 750 lines of code. So trying to troubleshoot bugs or program updates directly inside that highly nested, much larger structure introduces a lot of unnecessary operational friction. Another benefit of our internal schema is that it's standard agnostic. It gives us that flexibility to combine multiple different documentation standards or needs into one single file. So for instance, we're able to pack all of our data dictionary information, which is defined and governed by a separate ISO 19110 feature cataloging standard, right into our exact same file as our core metadata elements. This allows us to cross-reference our data attributes directly against our metadata rules while we're doing QC and without having to query separate systems. This standard agnostic schema also allows for tactical flexibility. Because our internal template is flatter and more straightforward, it acts as a universal pivot point for us. It's much easier to map and transform a GPMS formatted file into almost any other external data standard. So by keeping our primary records standard agnostic at the source, we're ensuring that if a new portal or platform emerges tomorrow requiring a completely different schema, we don't have to rebuild our entire underlying databases. We just have to write a new style sheet. We'll advance this to the next slide, and I'll give a breakdown of the actual transformation process to see how the code handles that programmatic translation. So as you can see by the technical flow on this slide, everything kicks off with our validated GPMS formatted metadata. From there, we programmatically introduce our custom XSLT style sheets, which act as a dedicated styling language for the XML data. In practice, these transformation files serve as a sophisticated coded crosswalk, and instead of actually having to manually alter text, the style sheet contains explicit instructions through the use of template matching and parsing rules to completely transform one XML document from one structure to another format. The style sheets read our compact internal GPMS schema, map out the elements, and dictate precisely how to arrange and expand that information into a brand new, fully parsed XML structure. Another bonus of the XSLT transformation engine is that it's not limited to outputting a single file type. Because it treats the source data as an independent resource, a single run of the transformation engine can actually split our data into two distinct products, our spatial metadata and our feature catalog. As a direct result of this XSLT transformation process that we just walked through, we generate an ISO formatted product metadata file. So what you're seeing here on this slide is a snippet of an actual production output. This XML file is fully structured under the ISO 19115-2 and 19139 standard schema, which is globally recognized for geographic information and metadata, meaning that our geospatial products can be immediately readable and by modern metadata catalogs worldwide once they're created and published. By running this automated version, we also ensure that the Census Bureau satisfies all national open data requirements, as well as our AI-ready best practices, allowing our core geographic data layers to seamlessly integrate with federated search engines. This is the exact file that external users and federal harvesting platforms interact with to find, access, assess, and download our data. So now that we've successfully created and transformed our files into compliant ISO formats, we enter what is probably one of the most critical phases of this entire life cycle, which is our validation and quality control phase. Generating a file that looks like an ISO file is one thing. Proving that it's technically flawless and structurally compliant is another. We don't ever assume that a file is ready for the public pipeline just because it's cleared our automated conversion process. Instead, we route our records through some of this automated QC flow that you see here on this screen. So as you can see, our validation flow moves through several distinct checks. It all begins with inventorying. Before we check the content, we want to verify the count. We make sure that every data set that we expect is represented in the batch. Next is the ISO schema validation. This is our baseline structural check to ensure that the syntax of our XML is perfectly adherent to the global ISO grammar rules. We then move into the invalid character and metadata values checks. These are kind of business logic audits where we're looking through the data to find any hidden symbols that might break a harvester or display improperly in a data portal. And then we also verify that the actual data values, like the dates and titles, are accurate and make sense for the data. From there, we then perform an XML difference analysis, which is where we compare this new file against a previously known to be good file and highlight exactly what's changed to ensure that no unexpected data was dropped in or, taken out of the file during the transformation process. And then finally, we run URL validation checks and what we call our geoplatform.gov checklist tool. The URL validation check verifies that every link in our metadata is live and functional. And then the checklist tool we developed based off of the FGDC technical guidance to make sure that the things that are suggested in their final checklist are included or have a reason to not be included in our metadata. So this is like our ultimate quality gate. If a file fails one of these checks, we have to halt the process and kind of work with the development to make sure that any errors are removed. But by enforcing these strict and historically informed rules, we ensure that our public deliverables are error-free before they reach that harvest preparation phase. So after clearing our comprehensive quality control, we get into the harvest prep and execution. This process begins by migrating our validated metadata files, the ones that just passed all the QC, onto our publicly facing external server. Once the files are in that location, we run another series of checks to make sure that all the files move properly and that the links are still working. And once those server-side checks are complete, we can deem the files ready for harvest. When we're ready to harvest, we use catalog.data.gov to interface and manually initialize the harvest. And then this signals to data.gov to begin harvesting our records into the federal repository. And then, of course, due to the sheer volume of our files, this process can take over 24 hours to reach full completion. And then historically, GeoPlatform would harvest the metadata from data.gov. And so this final execution phase is what ensures that our meticulous development and validation work actually translates into accessible, high-quality information for the public. So once that harvest cycle concludes, we don't simply just assume that our data has reached the finish line. We actually start doing additional QC, what we call our post-harvest QC. And that mostly consists of us making sure that what's in our web accessible folders that was harvested data.gov matches what's on data.gov. To do this, we use a custom Python script that leverages the data.gov API, and then it programmatically pings the repository to pull a comprehensive list of the Census Bureau files that were harvested within a specific time period of data.gov. And then again, like I mentioned, we run a comparison against the actual harvest source to make sure that no files are missing on data.gov and that everything harvested as we expected. We also do some visual verification and conduct on this, like some spot checks on the front end interfaces, just to make sure that the information is displaying properly and that there's no unexpected issues with data.gov. And then only after we complete these checks do we consider that the life cycle for this metadata release is complete. And this again ensures that the Census Bureau remains as a trusted source of accessible and accurate geospatial information. This slide represents kind of the payoff of what we see through this process. So what you're seeing here on this slide is a live production record or a screenshot of that from the data.gov page. And the most important takeaway is that every single piece of this information on this screen is populated directly from that machine readable metadata we just created, transformed, and validated. So when we look at this record for the 2020 census blocks for the state of Arkansas, we're seeing that interoperability at play. So that title and abstract you see at the top, they're pulled directly from our identification related fields in our metadata. The downloads and resources section, those links are exactly what we verified with our Python scripts during the validation phase. That spatial map you're seeing on the left is generated because we provided a precise bounding box. So this is a perfect example of how high fidelity engineering at the source creates a seamless, transparent experience for the end user. This metadata isn't just a requirement that we filled out. It's the actual data-driven engine that powers national transparency and discoverability. As we look towards the future, the work we've done to build this automated pipeline isn't just about maintaining status quo. It's about building a foundation for the next generation of geospatial data. And there's 4 key goals that are in our current plan. So first, we're hoping to expand coverage of metadata to additional public-facing products. We want to make sure that we have a unified, predictable experience for all of our users, regardless of what data set that we use. Second, we're focused on completing our transition to the ISO 19115 and -3 metadata standards. And that while we've made some big strides for that, we're still finalizing that and planning to implement those new standards in our metadata for our upcoming harvest of metadata for the Tigerline shapefiles this fall. And then third, we're already preparing for the next evolution of federal data cataloging in starting to adopt the DCAT US version 3.0 schema profile. Because we have a standard agnostic internal template, we don't have to overhaul again our other processes, but we'll be developing XSLT transformation logic that will act as our crosswalk to the standard. And then finally, this all culminates into actually publishing our geospatial metadata in the DCAT US version 3.0 profile schema profile. So I'm just going to leave with one final thought, and that is that we all know data has the power to enable evidence-based policymaking, drive massive innovation, and fuel economic growth. But data can only do that if it's findable and if you can trust it and understand it. Now is the time to start actively preparing and elevating our metadata practices to ensure that this momentum and innovation can continue. We have to build solid metadata for our data assets today so that they can be leveraged by all types of users tomorrow. Thank you all so much for your time and for letting me share about the Census Bureau's metadata journey and practices. I know there's a lot of people working towards similar compliance goals and modernization goals, so I'm really interested in collaborating and sharing ideas and troubleshooting, learning through each other's challenges. So my contact information is on this screen, and feel free to jot it down. with that, I'll punt it back to John, and I think we can answer any questions that folks might have in this Q&A panel, maybe.
That's right. Thanks so much, Allison. That was, as always, you're so passionate about metadata, and it shows. Really learned a lot. So there are some questions for you, but we'll give you a breather. As you've been talking for a while, you could go ahead and stop sharing your screen, and I think we're going to make it into a panel right now. So this session, we're going to be open it up for everyone. If they have any questions for a variety of geography division subject matter experts, there is a Q&A functionality. It should be on the bottom or bottom right hand of your screen. It's about 3 dots next to where it says chat, and you're able to enter questions in there, and we'll ask them of our panelists, just so you get a sense of who we have on today. And feel free to show yourselves visually if you'd like. We have Kevin Hawley from our products area, Maria Panachon-Tueve from our partnership area, Suzanne McCardle also from our geographic products area, Peter Virgil from our address area, specifically Luca. So I know we had a panel discussion yesterday about Luca, so if there's any further Luca questions. We also have Andrea Johnson on, our acting division chief, to answer hopefully most any other questions we have. And so I think we'll start with you, Andrea, if that's okay. I'm sure this comes probably from the news. Can you talk about the 2026 upcoming census test?
I can, but I think the best site to find out information about the 2026 census test is the actual website. I can pull that up in a second. I'm not it's underway.
Put a link at that.
And people are, working the test as they should. We've had respondents, we've had, things happening, but really I think the best source and the most current source is going to be on our census website. And I wonder if this is another scenario where we could put that specific 26 census test page into the chat, if you don't mind.
Yep, Meredith just did it. So if anyone is interested, you go ahead and look for that. All right, we have a question about I think, let's see what some good questions. Oh, Allison, we do have a question. If you've caught your breath, for how heavy was the lift when you first started to use and embark on this metadata standardization process?
I would say I kind of came into it after we had already established some practices. So I came into it at a period of kind of like refinement and improving to make sure that we were in compliance, as opposed to like actually initializing the processes that got us there. But I can tell you from being in different working groups that are establishing new schemas and from trying to implement a new schema ourselves, I think that if you take it in kind of a multi-step process, it makes it less daunting. So like initially, regardless of what format you intend to use, there's key metadata information you want to collect. And the sooner you kind of start collecting that information, like title and dates of your data and things like that, you can start to build that kind of foundation that you can, that's half the problem, is getting the information. Being able to put it into the structured standards, that's kind of the next piece. But as long as you have that information, it helps move things forward. And I think that's a big gap for anyone trying to start getting into metadata, is just that understanding, what kind of information you need to start collecting for your data and how to kind of do that in a systematic way so that you're standardizing what information you collect.
Great. We have another question. I guess we'll ask, this is a pretty broad question. I guess we'll ask Andrea this one. What data sources would you recommend that every local government should have available to the public or linked to the public from the Census Bureau? What do you think our most important sources
Is this a
are?
wish list? I mean, okay, so we, many of the presenters today have talked about a lot of the great maps and things. Allison's talking about metadata. We love to consume a lot of data that you have out there, whether it's, you know, road center lines, like your GIS files, having those available. Having parcels not only available maybe online, but working with parcel integrators so that we could absorb those into our processes. That's fantastic. Addresses, you don't have to necessarily give them to us, but we love when people upload their data to the National Address Database, which is a co-sponsored thing with Department of Transportation. We harvest addresses from that. We will take it all. But I think that in general, having an openness about your data, thinking about my own community, I am able to like look at my parcel. I can see imagery for my area. I can see the address for my parcel. Those are all kind of useful things for me as a citizen too. So I think you just have to kind of think about different use cases and like what's your end goal. But you know, Census loves consuming everyone's data. Our data would be nothing without your data, I think is the best way to put it. But like I said, we do consume it through nationwide sources like parcel integrators. Anytime you're working with the Postal Service, for instance, we're going to get your addresses through the Postal Service. We have a good relationship with them, right? You know, we get everybody's mailing address from the Postal Service twice a year. So sometimes even just working with other larger groups, DOT, Postal Service, parcel integrators is going to help us.
Yeah, wonderful, absolutely. All right, what one here? Oh yeah, Kevin, what data sources get the most downloads, views, and uses?
Okay, so I'll do my best here from what I know. I believe our Tigerline shape files are our most popular product. That's where most of the downloads come from. All three of our Tigerline formats, the shape files, the geo databases, and the geo packages, get a substantial amount of data downloads, and in that order. But I think shape files is definitely the most widely used. I know we started releasing the address count listing files recently, and that's become a very popular product. And we know that there's a lot of folks downloading those. I don't actually have the stats of all of our downloads in front of me, so I don't know, but I know that those are some of our more popular products right now.
I'm going to chime in and do a plug for the geocoder too. So every month we have millions of hits on our geocoder. And so whether they're coming from batch sources or whether the, you know, some are coming from individuals, the geocoder is really popular too. Sorry. Just had to add that in.
Yeah, that's right. I mean,
Yes.
we get 15 million plus submissions almost every day. So lots of use of that geocoder.
Absolutely, yes, that's definitely a very popular product used by all sorts of people. Speaking of the address count listing files, I have a question on this. The address count listing files are very useful in preparing for LUCA, and they include the count of GQ by block. Could the address count listing files be updated to include the count of GQ facilities by type? I guess this might be a Kevin or a Peter question.
And let Kevin answer that first.
I don't have the answer to that. We were able, I know we were able to release the 2020 counts by type at the block level, but I don't believe we have that same approval to do that on the annual product. Yeah, I don't know if anyone else has any other.
I'll chime in a little bit there. So one of the things that product's wonderful, and I bet you it would be nice to understand whether something's a university or a nursing home, you know, what the counts represent. But as Kevin mentioned, one of the ways we got authority to include the GQ counts every year was because they were sort of summarized at like GQ at the highest level, right? So that when we start getting into GQ types, you get into single digit numbers and we have some disclosure concerns. So I think we'll take that back as an action to say, like, is this possible and on what time frame? Just because I could see the usefulness of it. But it may just be that there's, in many cases, there's just one or not enough GQs. For
Absolutely, yeah.
disclosure reasons. Sorry, I should finish the sentence.
Yeah. That's very important. Absolutely. That's why those are some of the only files we have available to block level. All right, I have a question. I get more. I guess a lot of people are coming in with their AI and metadata related questions. I guess you really prompted a lot of people, Allison. Is everything that Allison just explained about structuring metadata broadly adopted by the industry at large? For example, would mobile app developers drawing on multiple geodata sets encounter the same data tagging and structures across private and public sectors, specifically public safety data?
You know, I don't know because I can't really speak to the practices that everyone's using, but we kind of talked about like community standards and how there's, we have schemas and representation to help make things have more specified information that you would expect to see like throughout like whatever geospatial file is available. So if industry folks have adopted those types of standards, then hopefully they would be collecting that information, but I'm not sure. I think it is a best practice to use these community-based and industry-based standards, and I do think a lot of people do, but I can't speak to all the data providers.
Okay, great. Yeah. And another one for you, Allison. Any resources for data organizations for, I guess, have you found any resources out there for organizations who are developing metadata standards with maybe a limited work capacity, like maybe an easy way to do it?
In short, no, because there's not much guidance in general out there for actually implementing. I think there's becoming more and more guidance out. I'd be happy to talk to you and even share, if we have, I think what makes things trickier is like, if folks don't start with like the same internal template or whatever, it's harder to share tools that can transform into new file formats and things like that. But like I said, we can probably share information. I'll check internally just to make sure that's something we can do. And I think we can, help provide some guidance. I can tell you I'm like a 1.5 person shop. And like some of these things that are out there are helpful, but a lot of the metadata guidance online seems to be kind of like when the Geospatial Data Act really got kicked off and then has kind of like petered a little since then.
Okay. So I guess everyone, if we could share resources, I guess that would be best. Let's see, what was another one? Lot of great questions coming in. Okay. I think this relates a little bit again to, I guess we'll have Suzanne answer this one. We talked about this a little less yesterday. They have missed some of the presentations, but your GeoWeb tools are nice, but I need to have geodata in spreadsheets. For example, I have a list of ZICTAs. I need to show where they are in a region for decisions. Industry data tools want to charge. Obviously, all of our data is available for free, and it doesn't transfer with the file. Does the census have a solution for a problem such as this?
Yeah, so I just want to make sure that I'm understanding. So the need here is a customer has a list of ZICTAs that they need to highlight or place on a map.
I suppose, yes, that's what it seems like.
Okay, so as far as I know, I can't, off the cuff, I can't think, like we don't have sort of a mapping tool where somebody can upload a list of geographies and display them on a map. Like TigerWeb does not have that capability. I'm not sure if data.census.gov has the capability to ingest a list of geographies or a custom set of geographies to display those on the data.census.gov dissemination platform map. I'm not sure if anybody else on the call now knows if that's something that can happen. I think that we have a data.census.gov presentation this afternoon after this roundtable. So I'm not sure if we could maybe take that back and learn, but I don't know if anybody else on the panel right now has a different read on that question or how we might accomplish that, or help somebody accomplish that.
I mean, from data.census.gov, you could pick those geographies from the list,
Yeah.
and then display them on the map. But yeah, I don't like Suzanne said, I don't think you can just ingest a list of them and have them display on the map.
All right, another an AI related question, Allison. What uncertainty metric should accompany AI inferred geospatial features when used for predicting outcomes, like access to resources or something like that? Is there some certain uncertainty metrics that you see accompanied use of geospatial data?
As far as like, so in practice, we're specifically just using data quality measures to kind of define the completeness or like omission of data. So I don't know if you're asking more about like confidence scores or levels.
I think that's where it is. Yeah.
So that's a little out of my wheelhouse for what we're doing here at the Census Bureau because I'm not sure.
Okay.
I don't know if Andrea or someone else who's familiar with some of the AI practices that we're doing here, how we're displaying that type of information.
All right.
I don't have too
Um,
much to add because I think like the AI that we're doing is like not exactly that where you're headed. You follow where I'm going?
Yeah.
Yeah.
Nothing to add. Sorry.
All right, I'm looking through some other questions again. Oh, this was we're sort of trying to answer this in the QA because it's a pretty long, detailed question. But I'll just open this up. I guess we'll start. Just I think it'll be a good prompt for discussion. People have noticed that obviously boundaries move through a variety of different programs. Can I guess Maria, if you could discuss how that process happens throughout the year, some of the different programs we might use that might change boundaries or roads and different updates, so that why a vintage from one year might change to another.
Okay, so this is primarily asking about legal boundaries.
Yeah, legal boundaries.
Okay. Yeah, so there's several reasons why you might see those boundaries change from different vintages. A large one is the Boundary and Annexation Survey. So that's an annual survey that's sent out to over 40,000 governments each year. And they're invited to send their legal boundary changes to the U.S. Census Bureau for us to update in the our Tiger database. So those can be submitted by either like the very local level. Sometimes we have partnerships where counties will report on behalf of smaller governments or states will report on behalf of the entire state. And in cases like that, some levels of government might see changes that they weren't aware of otherwise, or they were like, I didn't submit this, how did this get changed? That's one way that it can happen. We also have boundary quality projects where we look at like parcel data, or we gather boundary data from other partnerships, like with other federal agencies. And we have our own operations in-house to update those boundaries.
And I will point out one of the questions there was, I guess, was how are there resource links or documentation to see how and why that boundary might be updated on a public facing page?
Yes, but it's always good to inquire as well. With us, you can email geo.pass@census.gov if there's like a specific case that you have a question about. And we do publish the partnership shapefiles each year on our website. So you can go look at the existing boundaries, but on a case-by-case basis, why boundaries were changed. It's not like a one-size-fits-all thing. So you would have to get in touch with us to see about that specific case.
Yeah. And in addition, if you have questions today, or you just we don't answer them, in geo.geography@census.gov is a great resource for everyone. If you ever have any questions about census geography data, and we could forward them to the necessary area. All right, here's a question about, where was it? Oh, Luca, so Peter. If two overlapping jurisdictions participate in LUCA, say a county and a city within that county, and they submit their addresses, but there's differences in the address lists, how does the Census Bureau determine which addresses are the correct addresses?
All right. So starting off, the Census Bureau, right now, we're encouraging all governments to begin the collaboration process now. And definitely during LUCA prep and LUCA review, we want them to communicate with each other. As of right now, governments can begin looking at their block counts. We do have some tools on the LUCA website that they can review, look at their participants, address list, look at their blocks, and compare them to the census blocks. If there are differences, discover why they're comparing their block counts, the government should communicate with each other, try to work through those discrepancies, and try to figure out a way to make sure that those counts are accurate. So if a county and a city see there's different counts for a block, they definitely need to work together through that to coordinate and try to make sure that number is the same in the end. So I would say a coordinated approach with overlapping governments is needed. It will help reduce costs. It will reduce duplicative efforts. And if we do receive addresses that do conflict on different days during LUCA review, there is a process where our internal systems review, and there's a hierarchy set on those address updates. Our process takes place during LUCA review, as I mentioned, and since the government's participated, they will have an opportunity to review our updates that they submitted, and that process through the feedback and appeals. So that will happen after we receive it, we review it, and they will have the opportunity to look at the address updates that we provide through action codes and provide appeals if need be. So of course, we want them to collaborate now, try to make sure all the counts are the same, but if they do submit it, then there are some processes that we go through in our systems to make sure that we get the best address for our census address list. Thank you.
Yeah, wonderful. And I think, yeah, Meredith just put in the chat information about the LUCA program. So if you're interested, go ahead to that page. You can get started right away. So this is a, I'll ask this question to Suzanne, because actually yesterday, again, For those of you who may have missed yesterday, we had a full slate of presentations, and those were recorded and will be available at a later date for you to review. But we did have one question about electoral boundaries, congressional districts. So can you talk about how hold on a second, just Mr. So what's the Census Bureau's role in those congressional districts and creating those products?
Yeah, so I can speak to the timeline of those products. So a number of the standard products that we produce and release each summer based on our American Community Survey benchmark from Math Tiger start to become available in the summer. So you will see the 120th congressional district boundaries start to appear in TigerWeb, our Tigerline shapefile product, Tigerline geodatabase product, Tigerline geopackage, as well as our GRFC public product. So the geographic reference files, codes and names, the 120th boundaries, the 120th congressional district boundaries will all start to appear in those products that are released later this summer. The 120th congressional district wall map suite, we typically post for a new session of Congress in spring of the year that that session of Congress is effective in. So you should see those products in spring 2027. Yeah, I think that's what I have for you.
And I'll just add, can I add one more piece to the beginning of this process is each state works with the Redistricting and Data Voting Rights Act office to submit whatever changes are going to exist in the districts. So, you know, in the news, there's been a lot of discussion on districts changing. And so that office works with each state's representatives to capture those changes. And then that's how we put them into the Math Tiger system. So we don't capture them like just randomly. There's a whole process by which that happens. And they are the official district boundaries that we capture based on blocks. So that process is happening, you know, the redistricting office hosts that process now, and then it takes several months for that data to actually be put into the Math Tiger products that Suzanne spoke of. So hopefully that adds a little context. We get the data from the states, then we put it into Tiger, then we do some products.
All right. So one question was asked, and I'll just answer this one quickly because I don't think there's, unless someone forgive me if someone is an expert in this area, about the new construction program. How should government entities report major changes to address files after LUCA closeout before 2030 census, specifically new construction? That's part of the new construction program, which is ongoing, and we could put a link to that in the chat. Andrea, anyone else have any additional info on the new construction program?
To speak a little bit to new construction, not putting you on the spot, but it's your.
All right, just a second. Go ahead and talk about new construction. I think we do have some other team members here who can speak on if I don't hit all points. But new construction is basically the operation where we're collecting new addresses after the LUCA operation. So there's a timeline between, I think it's a 12-month span where we're looking for any new addresses that are close to the elements, have a roof, and are deemed new to a certain area. And they will be by census day. So usually we have an invitation list of over 39 governments we send an invitation out to. We allow them to provide updates, and we do try to process those addresses before census. And of course, they'll go through our same process of using our online tools that we have, such as GovsWeb, to provide updates to us. We're trying to go electronic this time for new construction. So any address updates that we do receive will be online, and then we can process them through our systems and add them hopefully to our census address list before census. Thank you.
Yeah, thanks. Yeah, that's great information. And again, that I think, yeah, they just put more information on some of our other programs. So if you have more questions about new construction or any of the other programs are available on that link. We have an interesting question. I'll start to answer it, but I'll just prompt the panel. It's about Alaska. So I know we have a lot of interesting Alaska's an interesting case study for the whole nation, but a lot of it is very consistent throughout the country. And the question was, would you have time help understand how the U.S. Census Bureau handles and displays Alaska's multiple geographies, boroughs, organized and unorganized, census areas, regional education attendance areas, etc. And so, yes, Alaska has a lot of different geographies that are sort of unique to it, but they do fit within our the layer structure and the different geographies we have throughout the country. They just may have different names. Boroughs are equivalent of counties, etc. So we do have many different layers of geography throughout the country, including in Alaska, which we handle through our different geographic hierarchy. We work very closely with the Alaska government and all of the stakeholders there that make their geography unique. Anyone else have any additional information they want to talk about our relationship and how we update in Alaska? All right. Yeah, that's again, so every state is different. Alaska has some more differences maybe than others, but every state is organized itself in different ways. And we try to handle all of those different organizations through our different hierarchies. I talked a little bit, I happened to talk a little bit about some of that yesterday about our general geographic hierarchies, not specifically about Alaska, but many of the other states as well. So that presentation will be available along with the other ones once the recordings are posted. So I guess we'll ask, we're a lot of great questions. We're heading towards the end. We want to make sure people have a break. There's a question here about how we handle housing unit loss. I'm not sure if they mean like in the housing unit viewer or in general. I guess we'll go with Kevin to discuss the viewer, but I guess we'll think about how we handle that in general if anyone has anything to add.
I think Andrea's trying to talk, but she might be muted.
Oh,
Sorry, I'm double muted myself. I'm gonna kick it off and then we're gonna go to Kevin because I think that he'll talk about the end product. So housing unit loss is something that we do capture. Right now, one of the way, like, so for instance, let's take an example. When there were the fires in California, we had indication from the Postal Service when an address was no longer receiving mail, and we are able to take that as an indicator that, hey, we want to check something out and we want to understand whether this housing unit is gone forever. And so we have internal tools that we can use to identify when when something is no longer, right? You know, we get a Postal Service file twice a year. That helps us. We also have imagery and other tools to identify like, oh, in fact, there's no house there anymore. And so we occasionally do terminate like a house, but really more what we do is we sort of say it's not there right now because it may come back. So housing unit loss is a tough problem. But sometimes when people are talking about housing unit loss, they're actually talking about vacancies. So within our structure and within our count of housing units, we include everywhere where someone does live or could live. So it might look like a housing unit loss in the sense that someone doesn't live there right now, but we're going to still include that in our housing unit count. We're going to still include that in our active master address file for pulling surveys and things like that, because you never know when it could change. It's a really temporal kind of thing. So that's a start. So that's sort of how we maintain. And also we would, through the LUCA program, I shouldn't give short shrift to Peter there. In the LUCA program, local governments can let us know, like, oh, hey, these are no longer, right? Like you think of a scenario like, I don't know if this happened, but like some big cities are terminating whole buildings because it's, you know, an eyesore and it's like a source of problems. So they terminate the whole building. They could let us know on within the Luca program that that building was no more. But now, once we have this in the master, these changes made in the master address file, it goes to a product. So Kevin, why don't we talk about like how we reflect that in the product?
Yeah, sure. So in the housing unit change viewer, what we do is we look at those current housing unit counts, and we compare them to the housing unit counts for the 2020 blocks that were available in the 2020 file. And so that way we can show that change both as a percent change and also as roll number changes. So Suzanne demoed that viewer yesterday. So if you haven't had a chance to check that out, check it out. It's the housing unit change viewer. So you can see at the state, county, tract, block group, and block level. And as you zoom into the map, those geographies change as you get, you know, further in, you get down to the block level, and it'll reflect that change. It'll show you that a block has gone from, you know, maybe 100 units to 200 units, and that'll reflect as a very big change, 100% change. And in some cases you will see losses. Some of those might be the sort of situation Andrew was talking about. Some of those could be conversions from they were housing units in 2020, but they really should have been group quarters. And so we've been working on a program that converts those to group quarters. So some of those losses aren't really losses per se, they're just reclassifications. Yeah, so that's a good way to see the change, and you can see that we're capturing this change throughout the nation.
Yeah, and sometimes what appears to be a loss, just one more thing to add to what Kevin was saying, is actually like we found a more appropriate geocode for it. So maybe we had a house and we realized, oh, we have it geocoded to the wrong side of the street, and now we've corrected that geocode. So in the viewer, it might look like a loss, but really it's a gain on the other side of the street. So it's really important when you're using that viewer to kind of consider context.
Wonderful. Thank you so much. And thanks everyone for all the questions. Thanks so much to the panel for being here and answering them. Again, if you have additional questions, go ahead and email us at geo.geography@census.gov, and we'll send it to these great people and many of our colleagues throughout the division and the agency itself if we need some assistance. And throughout the day, if you have any questions that just come up, you could put them in that Q&A chat, and we will answer them in that chat or forward them as necessary. So again, thanks everyone on the panel for joining us. Thanks so much. So we're going into a short break. Please join us back around 2 o'clock where we have our final session of this conference. We'll talk about a lot of the great different applications with used census data, including some of our partners here at the Census Bureau, as well as some great external presenters. So you won't want to miss that. So thank you so much. Please return by 2 o'clock. Thanks so much.